Okay, we're going to go over a couple examples on the molarity homework and kind of give you guys a basic idea of how these problems are supposed to work. So the main concept of molarity is that it's a measure of concentration. It's saying how many atoms of this substance are in a given volume. Right? So, and the way that we express that, the unit molarity is measured in moles per liter. Okay? So here, let me show you my paper. So anytime you see this big capital M, what that means is it's telling you concentration. It's telling you how many moles are in 1 liter of that solution. Okay. The real life example of this that you guys might know, or that might kind of make sense, is sweet tea, right? Some restaurants put a lot more sugar in it than others to make it more sweet. So the ones that are sweeter and have more sugar, you would say have a higher molarity of sugar, right? There's more sugar per liter in that sweet tea than in the restaurant that doesn't use as much. Okay. So when we're looking at the homework, these first 6 are asking you to calculate molarity. So for number 1, it gives you moles and it gives you liters, right? The question is 0.444 moles of cobalt chloride in 0.654 liters of solution. So on questions like this is about as simple as they're going to get, right? It's asking you to find molarity, which is unit of moles per liter, and it's giving you moles and liters. So in order to find it, all you got to do is divide. You say moles over liters. Oh, I guess it would help if I showed you guys the page, huh? Sorry. You say moles over liters to find molarity. So we'll plug in the 0.444 moles over 0.654 liters. And when you do that division, that'll give you the answer of the molarity for this solution. So let's go over here and say 0.444 divided by 0.654. And that comes up as 0.67899, blah blah blah, whole lot of decimals. On this one, same as the one from the day before, I want you guys to round everything to 2 decimal places. So we're looking here, 0.678. The 8 tells us that this one should round up. So our answer here is going to be 0.68 molar. It's the concentration of that solution. Okay, that's about the simplest one on there. It's the bare bones basics of how it works. Okay, some of these other ones are a little bit more complicated. So they're giving you grams, and they want you to find molarity. Well, in order to do that, you have to convert from grams to moles, which is what we were doing in the previous lesson. So this is kind of bringing it all together, right? Some of the other ones go even a step further than that and give you kilograms or milliliters instead of grams and liters. So you've got to worry about converting units there. That's one thing you've got to pay a lot of attention to. Otherwise, you will definitely get thrown off and have answers with the decimal points in the wrong spot because you forgot one of those metric conversions. Okay, so we'll do an example of one of those. Let's look at number 4, I think, is a good example. Because in that one, instead of giving you grams, it gives you kilograms. Right? And it wants you to say how many moles are in, or sorry, what is the molarity of 10.5 kilograms of sodium sulfate in 16.8 liters of solution. Okay, so like I kind of mentioned earlier, there's 2 big steps here. One, we've got to get this gram or kilograms converted to grams. Then we've got to convert that to moles, and then from there we can go to molarity. Alright, so the way we're going to do this is the same way we've been doing everything for the last few weeks, is by setting up a dimensional analysis problem. We're going to start with what they've given us, our 10.5 kilograms, and we know that eventually we want to use that to figure out how many moles of this substance we have. So first things first, we've got to go from kilograms to grams, because the only way we know how to convert from mass to moles is by using grams in the molar mass. So from kilograms to grams, that's one that isn't going to be on your conversion chart or anything like that, because it's just a basic metric prefix. The prefix K, or kilo, means 1,000. So a kilometer is 1,000 meters, right? A kilogram is 1,000 grams. A kiloliter would be 1,000 liters. It's that's what it always stands for. So what we're going to say is 1 kilogram, and we'll put that on the bottom because it's on top over here. And we're going to say that is equal to 1,000 grams. Okay. So when we've got that far, we have kilograms on top and kilograms on bottom. So those units are going to cancel each other out. And now we're looking at grams as our unit that we're left with. Our end goal is to get this in moles. And if you did the assignment from yesterday, you should have a pretty good idea of how to convert from moles to grams, or grams to moles, or vice versa, right? The way we've been doing that is by using the atomic mass, or the molar mass, of the formula. So we're going to go over here, and we're going to write out the elements that we have in this formula, and then we're going to figure out what the atomic mass is for each one. And again on this, just like the earlier lesson, I want you guys to round the atomic mass of the elements to the nearest whole number, right? There's no need to use all those decimal places. The nearest whole number is good enough for what we're doing. So we're going to go over here. We're looking for sodium, so Na, it's right here on the left side, and its atomic mass is 22.99, so we're going to round that to 23. Sorry if you guys can hear the dog running around in the background, but he'll calm down in a minute or two. The next thing that we're looking for, if we go back and look at our list here, is sulfur. So we've got to find sulfur. It's right over here on the right side, and it has an atomic mass of 32. And then our last one was oxygen, which the nearest whole number to that is 16. Okay. So we found the atomic masses of each one. And our next step in finding the molar mass is to multiply each of these by however many of them there are in our formula. So for the Na, the sodium, we're going to multiply it by 2, because it has that little subscript 2 there. The sulfur, there's only one of. There's no subscript there, no parentheses or anything like that. So sulfur just gets multiplied by 1, and then the oxygen is multiplied by 4. Figure out what all these come out to. So 46, 32, and 64. And then add them all together to find the total molar mass. So let's see, that would be 8, 12, and then 14. 142 grams per mole. Okay, so now that we know a conversion between grams and moles, we can use that here to figure out how many moles of this substance we would have. So if we've got grams on top here, they've got to go on the bottom over here. So say 142 grams in 1 mole. Grams cancel each other out. We're left with just moles. then we can multiply everything on top together. So 10.5 times 1,000 comes out as 10,500. And then on the bottom, 1 times 142 is 142. Plug that into your calculator, and you'll figure out how many moles of this substance you have. So we've got 10,500, oh, that's one too many, divided by 142, and that comes out as 73.94 moles. Alright, so if we were doing the assignment from yesterday, that would be where we stop, right? Because we've converted from mass to moles. But in this one, it's asking for molarity, for concentration. So remember, the formula for that is moles divided by liter. You can see right up at the top here. So our last step here is to take however many moles we found and divide it by the number of liters that it gave us in the problem. So 73.94 moles divided by 18.6 liters, and that will give you your final answer. .975 is going to round to 3.98 molar solution. Alright, so that's how you're doing all of those ones in the first chunk, these first 6, where it's giving you mass or moles and volume, and it wants to know what the molarity is. Okay, these bottom 4 are a little different. You're going the opposite direction, right? It's giving you the volume of the substance that you have and the concentration, and it wants you to find the mass, how many moles of it, and the mass of those moles. Okay, so that is exactly like what we did in class before we went to the lab to do our Christmas ornament project, where we were trying to figure out how much of each compound we needed to mix to get the right concentration solutions. So it's the same exact process there, right? So we'll work through number 7 together as an example. So it's telling us there in number 7 that we have 2 liters of an 18.5 molar solution of sulfuric acid, which is H2SO4. Okay. So the way we're going to solve these, just like everything we've been doing lately, again, is dimensional analysis. This is a tool that's going to help you out pretty much the whole rest of the year in chemistry. You've got to know how to do it. So we're going to start setting things up by starting with what we're given. We're for sure told that we have 2 liters of this solution. So we're going to start with that. Alright, and the main things we want to know in this problem, we're looking for the number of moles, and we're looking for the mass, which is going to be in grams. Alright, so once we know the volume that we've been given, we can use this concentration as a conversion to get to moles, right? That's why this is a useful unit. If we know it's 18.5 molar, that means there are 18.5 moles in 1 liter. So we can set that up as a fraction here in our dimensional analysis. We can say 1 liter, and that's got to go on the bottom because the other liter is on top over here. We can say that's equal to 18.5 moles of this solution. Okay, and right there after one step, we've got this answer for how many moles we need, right? The liters cancel out, we're left with just moles. So right there, we're halfway done. We multiply everything on top together. 2 times 18.5 is 37. And on the bottom is just a 1. So 37 divided by 1 is 37. It doesn't change anything. So we know we've got 37 moles of this solution. Okay. Then from there, it's exactly like what we were doing in our previous lesson. We know the moles, we know the formula, we're trying to find mass. So all we're going to do is set up dimensional analysis again and find the molar mass of this formula to convert to grams. So we'll say we know for sure we've got 37 moles. We just need a conversion from moles to grams. We can do that by finding the molar mass of this formula. So we'll go back to the periodic table real quick. We're looking for hydrogen, which has an atomic mass of 1. We're looking for sulfur, is over here, has the atomic mass of 32. And we're looking for oxygen, right above it. It has an atomic mass of 16. Okay. We multiply each one by however many of it are in our formula. So for hydrogen, we're going to multiply by 2, because it's H2SO4. The sulfur, there's only 1 of. And then the oxygen, we've got 4 of those. So when we multiply it, it comes out as 2, 32, and 64. If we add them all up, sorry, I should have given myself a little more room there. But if we add all those up together, it comes out as 98 grams per mole. So that's the conversion we're going to use here to get to grams, right? We know 1 mole weighs 98 grams. Our moles cancel out. We're left with just grams, so we're good. All we've got to do now is multiply. 37 times 98 comes out as a big old number. I don't know off the top of my head. So let's plug it in our calculator. So that's 3,626. And then the bottom is just 1. Right? So just 1. Divide anything by 1, it stays the same. So your answer here would be 3,626 grams. So for this problem, 2 answers are, you have 37 moles, which is equal to 3,626 grams. Okay, the other 3 are the same exact process. So you guys work through as many of these as you can. Let me know if you have any questions. We can always set up a Zoom call if you're an online student and you need some help, or shoot me an email. I'll do what I can to answer you. And if you're in person, just raise your hand and I'll help you out. Alright?